In this tutorial, I am going to show you how to evaluate metagenome assemblies using the tool MetaQuast. So by the end of this tutorial, you'll be able to generate a report such as the one being displayed now. So in this tutorial, I am going to evaluate this metagenome assembly, this one here. If you want to obtain this data, then check the description box. There's a link to the tutorial that was used to generate this data. That tutorial shows how to obtain the FASTQ files, assemble the data, and generate this output here. So make sure to watch that video. In addition to the data, you should also have QUAST installed. We'll use QUAST to install the evaluation tool, i.e. QUAST. If you already have QUAST installed, then that's fine. But if you don't have it installed, then make sure to install QUAST. I also have tutorials that show how to set up QUAST. So check the description box, you'll find links to those videos. Now let's open the terminal and start the exercise. Okay, so we are now going to install QUAST. So before we install QUAST using QUAST, we need to add channels. We will add 2 channels. So I'll say QUAST config add channels. I'll start with bioconda. I'll add a second one. So I'll say QUAST config add channels. The second one is QUAST forge. Now I'll create an environment and install QUAST in it. So I'll say QUAST create-n metagenomics, and I'll specify QUAST. So let's install QUAST now. Okay, so now we are going to type Y to confirm and then hit the enter button. So once we do that, QUAST will download all necessary packages and then install them for us. So let's wait for QUAST to complete its work. Okay, QUAST has been installed. So if we want to use QUAST, we will need to activate the environment. So there is the command. But before we start using QUAST, we also need to get an additional resource, and that is the server database. MetaQuast uses some of the genomes in the server database for the analysis. So we need to get that. So we will use this command to download the server database. So let's activate the environment first and then call this command to download the server database for us. So let's say under activate metagenomics. Now let's issue the command to download the server database. So I'll say QUAST download server. So let's execute this command. Okay, the server database has been downloaded and configured, so we can proceed. So now we are going to evaluate the assembly. So let's ls to check the file. So we are going to do this. Let's ls into the megahertz_result directory. This has the assembly. So we are going to supply MetaQuast with this file, and then the evaluation will be done. So to evaluate the assembly, we will say MetaQuast, and then we will say -o, and we say MetaQuast_results. So this directory is the output directory. So this directory will be created, and then the report will be saved in this directory. Now let's specify threads. So we say threads, and I will say 4. Now the number of threads, you can increase it if you have more capacity. I'm using 4 because I'm running this on my normal laptop. But if you're using a Linux cluster, let's say an HPC system, then you may have more cores. So you can increase this to the number available to you. So whether 8, 10, 20, whatever, you can do that. But I'm using 4. Now we need to specify this file. So we say megahertz_results / final.conti.fa. So this is how we do it. Now with MetaQuast, it's possible to also specify the FASTQ file. So if you specify the FASTQ file, then read mapping success will also be made available to you. There will be a report for reads mapping, but if you don't specify the FASTQ file, then we will not get the reads mapping statistics. So with the read mapping statistics, we need to specify FASTQ. The requirement is that you need to have enough space when you are specifying the FASTQ files, because you need a lot of space. So for now, I'll use this command, but if you want to add a FASTQ file, then you have to make sure you have enough space. So if you want to add a FASTQ files, that's how we do it. Let's open a new terminal. Let's activate the environment here. So let's say MetaQuast. That's the help. So to add the FASTQ files, we have to use this flags here. That's just PE1 and then that's just PE2. This is because we have paired and reads. Let's take a look at it first. I think I'll do that first. Let's say ls FASTQ. We are going to find this and then this. So that is why we need to use the dash PE1 and dash PE2, which are all here. So this and then this. So take note of that. So if you want to specify the FASTQ files, then in addition to this, let's just put it here. You can just say dash PE1, then say FASTQ slash, then you bring your read one, dash PE2, then you specify your read 2, and then you also indicate your final.contigs.fa, the assembly file. But I will skip it, by the way, because it will take time. So you can choose to do that as well. But for now, let's stick to this. So this one is simple and straightforward. So I'm going to start with this, and later, if you have space, you can just add the other flags to include the FASTQ files. So for now, let's execute this command. Okay, now we have executed the command. So MetaQuast will start performing the analysis. So let's wait for MetaQuast to complete its work. Okay. The evaluation has been completed. So let's take a look at the outputs. So let's say ls. We are going to find a directory called MetaQuast_results. So let's ls into it. And we are going to find our files here. We have some directories as well as some files. So we will look at the HTML files. We have one here, which is report.html, and we also have this one here, Icarus.html. So we are going to open both files using our internet browser. So let's take a look at these files with our file manager, and then we can open them. Okay, so this is the directory which has the MetaQuast reports. It's called MetaQuast_results. So let's open the directory. When you open it, you are going to find some subdirectories as well as some files here. We have two HTML files. We have report.html and Icarus.html. We are going to open both reports. Well, but let me just say we are going to open both files using our browser. So we will start with the report.html. So let's open this one. So when you open it, you are going to find something like this. Of course, you can enlarge it or you can also make it smaller. That is up to you. So when you are here, you'll find some notes here which I will encourage you to read, especially if you're a beginner. And then you're also going to find your assembly statistics here. So the assembly statistics have been grouped. We have genome statistics, reads mapping, misassemblies, mismatches, statistics without reference. So all these are there. A description of each of these measurements can be found if you hover your mouse or your cursor on that particular measurement. So this one, for example, genome fraction, if you hover your mouse, you are going to find the definition. Again, let me just say this one, for example, genome fraction, if you hover your mouse on it, you are going to find a definition that has been shown for you. So the same applies to all the other measurements. We also have some plots here that you can view. So we have different plots. You can click and then check the various plots. So just explore. Okay. There is also corner charts here, which you can view. So just click it and then you are going to find it here. This corner chart was generated because MetaQuast used some reference genomes in the analysis. So that is why we have that here. So you can just use that to check the components. Let me just say the species or organisms that are in your data. So you can do that and then get a breakdown here. Okay. I've already covered a tutorial where I showed how to explore the corner chart. So I'll leave that video in the description box for you to check. So I will skip a detailed explanation of this one. Now let's go back. So if you want to go back, just come to the arrow here, click it, and then you'll be sent back. We also have, let's just scroll down. We also have a detailed report. Now, with what we have, this is a short report. And so if you want a detailed report, you can click on the external report. Some information by default are not displayed. And so if you want a detailed report, which will bring up that information or those hidden information, you can click on external reports and then you have all that given to you. So that's how we do it. Now let's click the short report and then get it done like this. Because MetaQuast use some reference genomes, it will also be important to get a breakdown. Let's take the genome fraction again. The genome fraction, the definition says genome fraction is the total number of aligned bases in the reference divided by the genome size. Okay, so that means there is some form of mapping. Okay, MetaQuast does some mapping. It maps the data we have, the context to the reference genomes. And so this is the genome fraction. It tells you the fraction. So because MetaQuast use multiple genomes, if you want a breakdown, then you can click on it and then you get a breakdown. You get to see the reference genome that were used. You're also going to find their percentages here. So this will help you to get a better understanding of your data. And the same applies to the others. Now, if you want to hide the breakdown, you can just click that section again and it will be hidden. And then you can check on the other ones too. So click and then you are going to see all of them there. So you can try your hands on all these ones. Now let's check something. We have our summary statistics. So it will be good to also compare the values we had here to those that have been made available on the Glance tutorial page here. We are going to do that also. Now, if you run MetaQuast with multiple files or multiple samples, then you are going to find each of these files, their respective values in different columns. At the moment, we use just one file or one sample, and that is why we have one column. That is the final with context. So it's possible to run MetaQuast and specify multiple files. With the command that we used, the read mapping statistics will not be available to you. So if you want to get a read mapping statistics, then you have to specify the FASTQ file. So just check and use the instructions that I gave earlier on. Now we are going to compare what the values we have here to what has been given here. I'll do a few and then I will encourage you to do the rest. This is just an intro. So let's take, for example, the genome statistics. We have the genome fraction. It says here, the definition is here. And then we also have some questions. It says, what is the genome fraction for this sample and then this sample? And which reference genome has the highest genome fraction for this sample and this sample? Of course, we use this sample, so we will talk about that. So we have the answers here. The genome fraction is 30.22% for this sample. And the higher genome fraction was found for this reference genome. Let me just go back. Was found for this reference genome. Okay, so This is where the information I gave you comes into play. And so when you go back to a report, genome fraction, for example, it says 30.818. When we compare, here it's 30.22%. So the difference is very, very small. Of course, it would have been good to get the exact same value, but sometimes you may not get it like that. It depends on a number of factors. It could be possible that maybe the version of software we use, the version of MetaQuast we use, maybe operates slightly different from the version that was used for the glide tutorial. That's also possible. It could also be that the server database that we use is slightly different in terms of the reference genomes in the slightly different from the one that was used in the glide tutorial. So that will also be a factor. And then some of these softwares too, they are a bit stochastic. So that means there's some form of randomization. So that also leads to we not having the same value, even if you run it multiple times. So that's also a possibility. But once the values here are almost the same, things are looking good. So I wouldn't be worried that the values are not equal. Okay, so once the differences are not much, it's fine. Okay, so that's for the genome fraction. Okay, and you can also check it using the plot here, and then you find that information. So when you click the genome fraction, you're going to find a breakdown, and we see that the highest was found for this organism. And that is what has been given here. Let's just check. That is what has been given here. So things are looking good. You see here it says 84.4%. And here it says 84.169. So they are pretty close. So that's also good. So we can click it back, and then the breakdown will be hidden. Now you can try with the other questions too. It's basically the same approach. So when you read the question, you check the answer, and then you can come to the report here, and then check where that statistics can be found, and just click on them. If you can't find what you are looking for, you can just click on the external reports, and then you have the details given to you. So try that, and then you'll be fine. Okay, let's go back to the short reports. So try with all the questions, and then let me get your feedback. Now let's move on. Here, I will encourage you to read about it. It's very important. That's the coverage. Try to read about it. Now let's move on. Let's scroll down and then check another thing here. You will scroll down to the Icarus config browser. So this Icarus config browser is also an HTML file that you can view. I showed it earlier on. So you can use that to visualize the contigs. Okay, so if you want to go into details with the contigs, maybe check some additional information, you can just use that. So a brief description has been given here, so I will encourage you to read more about that, then use that to understand your data. So let's look at how to view how to open and then view the content in the Icarus content browser. So here it says content size viewer. So we are going to also look at this one. So when you are here, there are two approaches, by the way. So when you are here with this report, when you are here, just check here, the upper part here, you are going to see this text, view in Icarus config browser. So when you click it, you're going to find something like this, and then you can click on the config size viewer, this one here. So when you click it, it will be shown for you, and then you can view whatever you want to view. Of course, we have some interpretations here about the colors, so you can check that. That will help you to get a better understanding. So if you want to go back, you can do that. You can click on main menu, and then go back, and you can click on QUAST reports. And you can also check some details for each of the reference genomes. If you want to check the reference genomes here, when you click on each of them, you have the visualization shown for you. So you can also do that. That's up to you. Another way to open the Icarus browser is to use its file. Let's check. So when you are here in the MetaQuast_result directory, you'll find this HTML file, Icarus.html. So just click it and then it will be open for you. So it's the same thing. So when it's open, you can just click on config size viewer and then check what is there. You can go back, or you can just use the main menu. You can go back and then check all these other ones too. So it's possible to do that. So just try your hands and then let's see how that goes. So that is a summary of the MetaQuast reports. We also have this one, config alignment viewer, which we talk about. So the config alignment viewer is what we just did. Yeah, those are the ones here. We just looked at them. So you click on each of them and then you see the alignment details. So just check if you want to do that. Yeah, so that's it for the MetaQuast reports. There's a summary, by the way. So just make sure to check this guy's tutorial, and then you will have some useful information to help you to interpret your data and also explore. That's basically what I'm going to say. So that is it for the MetaQuast reports. So now that we are done with this exercise, I will encourage you to check this playlist for more metagenomics tutorials.